Hi everyone, welcome to Vijay Datta chemistry classes. This is Purnima ma'am. Today we are going to learn numerical calculations based on chemical equations. So let us see what are those numerical calculations in the chemical equation. See, when we are seeing one chemical equation or one chemical reaction, that chemical reaction gives what is the information it is giving. So calculations based on chemical equations are known as stoichiometric calculations. So whatever we are doing now, those are said to be stoichiometric calculations. So in these stoichiometric calculations are several types. So that calculations based on weight relationship, weight volume relationship, and volume relationship. Weight relationship, weight volume relationship. Let us see first one. What is weight relationship? Weight relationship is nothing but the relationship can taken place from the reactant side and product side also. See here, I will generalize statement, one statement I will take. So they have given one reactant. So weight is nothing but both for reactants and products we have to consider their atomic weights. Okay, their atomic weights. According to the atomic weights we will solve the problem. What is weight volume relationship? Weight volume is nothing but with respect to that, with respect to weight volume relationship, if you are taking reactants with respect to atomic weight, then they asked products with respect to volume, you have to take 22.4 liters at STP. Okay, so 22.4 liters as a reference we have to take volume. Suppose volume relationship they asked, volume relation between the reactants and products, volume relationship they asked. So both reactants and products we have to take volume at STP, that is 22.4 liters and 22.4 liters. Okay, so I think what is this atomic weight, what is this volume, like that you are getting. Let us do some numericals, then you will understand. Okay, let us see the first type of calculations, the stoichiometric calculations based on weight relationships. So first one is calculations calculations based on weight relationship. So see here, I am taking one problem. The weight of oxygen gas, the weight of oxygen gas liberated by the liberated by the heating of liberated by the heating of 2.45 grams of KClO3 is. So here he is asking the weight of oxygen gas liberated by the heating of 2.45 grams of KClO3. So both asked in weight. The relationship both are in weight. So what is this weight relationship? See here. So first of all, whatever the question he given, we have to write the equation for the given question. The weight of oxygen gas liberated by heating of 2.4 grams of 45 grams of KClO3. So KClO3 on heating produces oxygen gas. We know the reaction. Along with the oxygen, it produces potassium chloride also, KCl. And see here, whenever we are doing the stoichiometric calculations, first of all, we have to balance the equation. This is not a balanced equation. So let us balance the equation. This side is one potassium, one chlorine. But this side is three oxygens, this side is two oxygens are there. So what I will do, you multiply here with 2. You multiply here with 3. Now let us check the oxygens. 3 2s are 6 oxygens. This side 2 3s are 6 oxygens. But by adding 2, by keeping 2 here, potassium and chlorine moles changed. So just simply add here 2 KCl. Now it is also 2 potassiums, 2 chlorines, 6 oxygens. 2 potassiums, 2 chlorines and 6 oxygens. So whatever the reaction we have taken here, that is a balanced chemical equation. So whatever the stoichiometry calculation you are doing, the reaction must be balanced first. Okay, now come to the question. He is asking weight of the oxygen. Weight of oxygen gas liberated by heating 2.45 grams of KClO3. So he is asking question, 2.45 grams of KClO3 is heated. How much amount of oxygen will be liberated? To solve this question, we have to take the initial weights of KClO3 and O2 from the balanced equation. Let us see what is the KClO3 atomic molecular weight. Potassium. Potassium is 39. Chlorine is 35.5. One oxygen is 16.6, or 3 oxygens are 16, 3s are 48. If you calculate this, you will get 122.5 obviously. So, 1 mole of KClO3 weight is 122.5. Like that we have here 2. So, 2 into 122.5 grams of KClO3 is giving 3 moles of O2. That is nothing but 3 into oxygen is how much? 16, right? One oxygen is 16, like that we have a 2 oxygens 32 grams, 3 into 32 grams. Now the question, 2 into 122.5 grams of KClO3 giving 3 into 32 grams of oxygen. Then 2.45 grams of KClO3 gives you how much? Suppose if you are considering it is as x, simple cross multiplication. X is equals to 3 into 32 into 2.45 by 2 into 122.5. You calculate, you will get the answer 16 to 0. So if you calculate this one, you will get the answer. Okay, so suppose it will be 0.96 grams. You calculate this like this. You can ask, why did you take here 122.5? He given here clearly the weight relationship. The weight of oxygen he is asking, the weight of KClO3 is given. So he has taken the weight relationship for the reactants and products. Reactant is taken in weight. He is asking the product also in terms of weights only he is asking. Suppose if he asking weight volume relationship, we can take in weight volume relationship. Let us see another problem in weight relationship only. See, I'll go for the next problem. How many grams of 80%? How many grams of 80% pure marble stone? Pure marble stone on calcination give 14 grams of quicklime. We should know the formulas of marble stone, quicklime. That one we should know. See, what is the question he asked? How many grams of 80% pure marble stone on calcination give 14 grams of quicklime? See here quicklime is nothing but calcium oxide and marble stone is nothing but calcium carbonate. CaCO3 on heating gives rise to CaO plus CO2. Isn't it? So, see here. He is asking the question, 80% pure marble stone on calcination gives 14 grams of quicklime. Actually, these both are in weight relationships only he is asking. So, calcium carbonate weight is 100 grams, we know. 100 grams, because calcium is 40, carbon is 12, 16 threes are 48. If you add that, we'll get 100 grams. He is asking for quicklime, so that is nothing but calcium oxide. You have to check either the reaction is balanced or not. One calcium, one carbon, three oxygens, this side also three oxygens, equation is balanced. So 100 grams of calcium carbonate is producing, calcium is 40, oxygen is 56. So 56 grams of calcium oxide it is producing. So to produce 14 grams, how much amount of the calcium carbonate is required? That is the question. So suppose if you assume that is as x equal to 14 into 100 by cross multiplication ma, 100 by 56 grams. If you do this, obviously you'll get 14 fours are 56, 4 25 is 100. So obviously 25 grams. 100 grams is giving 56 grams of calcium oxide. Then 14 grams will be given by 25 grams only, right? So 25 grams of calcium carbonate is required. But here the question is not completed because he said 80% of pure marble stone. So here it is a percentage purity. Percentage is not 100%, he said. If he said 100%, then we can close this problem with 25 grams. But he given percentage purity is 80%. So 80 grams of CaCO3, 80% is nothing but 80 grams of CaCO3 will present for 100 grams. We have calculated for 100 grams, but we have to calculate for 80 grams now. So 80 grams of CaCO3 is equals to 100 grams of calcium carbonate and 100 grams of marble stone. Then 25 grams of CaCO3 is nothing but how much? See here. So 100 into 25 by 80. 100 into 25 by 80. That gives you 31.25 grams you will get. 100 into 25 by 80 will be gives the 31.25 grams. See here. Actually, first we have taken 100 grams, right? So 80 grams will be present. That is nothing but 100 grams of marble stone might is. 80 grams of CaCO3 will be present in 100 grams of marble stone. Then 25 grams of CaCO3 present in how much amount of the 100 grams marble stone? Because we have to calculate for marble stone only, no? So that is 31.25 grams. 25 grams if it is 100%, as it is the 80%. So we calculated 25 by 80 into 100. Simple calculation. 25 by 80 into 100, because if you are calculating for 100, so you can calculate 25 by 100 into 100, but you have to calculate for 80% only. So whatever you are getting 25 grams, that 25 grams into 100 by 80 it will be. So this is the problem based on weight relationship, right? Let us see weight volume relationship. How he will ask weight volume relationships, calculations based on weight volume relationships also. Let us see the first problem. The volume of CO2, the volume of CO2 gas liberated at STP by heating 5 grams of pure limestone is. The volume he is asking, but he given in 5 grams of pure limestone. So one is in weight, he is asking CO2 is volume. So this is called weight volume relationship. Let us write the reaction for pure limestone and calcium, carbon dioxide. So that is CaCO3 gives rise to CaO plus CO2. Actually, it is 100 grams, it is 56 grams, and it is 44 grams. Yes. So, but here it is according to the weight. But he is asking that pure limestone means calcium oxide is for 20 volume. So what we have to take if they given the volume, you have to take it for 22.4 liters at STP. So 100 grams is giving 22.4 liters of calcium oxide. Then 5 grams of pure limestone gives how much volume? The volume of CO2 gas liberated at STP. Okay, he given for carbon dioxide ma. Volume of CO2 gas. Volume of CO2 gas liberated. That is also 22.4 liters only, because both are 1 mole only. No, it is 1 mole of calcium oxide means 22.4 liters. Carbon dioxide means 22.4 liters. Both are 1 mole only. If they given 2 moles of CO2, then you have to multiply 2 into 22.4. If they have given 3 moles, you have to multiply with 3 into 22.4. So simple calculation, if it is x equal to 22.4 into 5 by 100. If you calculate this one, you will get the answer. 22, 5 2s are 10, it is 20. If you calculate the 20, 11.2, 11.2, 11.2 by 10 it will be. So 1.12 liters you will get. So 1.12 we can consider liters like. Okay. Okay guys, thank you. The remaining one more relationship, volume relationship, we can go for another video. Okay. Thank you students. Thank you so much.